Okay, so now we're going to apply the vector concept to airplanes. Obviously, airplanes don't fly in a vacuum, so they've got that wind that they've got to fight against. I mean, if you've ever traveled across the country, you know that it takes less time traveling one direction or the other because that wind's either going to speed it up or slow it down. So what we do is we've got our plane that's flying 425 miles an hour on a bearing of south 24 west. So we're going to draw that right here. We're going to do a good job of being pretty accurate with our measurements or our estimates of the magnitude. And this would be the 425 miles an hour. That's the magnitude. Then the wind, you can draw it from the same location because they're both acting on that same point. But remember, it's easiest to just find the resultant by drawing the wind where the plane stops. So we're going to go north 53 west. So that's about here for 36. So compared to the 425, the 36 should be quite a bit smaller. What is the 53? So I know if I make this a little bit bigger, that angle is 53. And then from alternate interior, this angle is 24. So in total, this angle is 77 degrees. I'm going to label the 36. You can read that. I need to find the resultant, which is this right here, and that's going to be the actual speed and path that the airplane takes. And it makes sense. The plane is flying, that wind is pushing it up just a little bit more north than what it took off from. The final resultant, when you guys solve it for x, think law of cosines again, should be pretty close to the 425. I mean, you're not going to come out here, a 36 mile an hour wind is not going to change the speed of the airplane that drastically one way or another. But it could be 400, it could be 450, somewhere in that range. Just know that going in. And then we also want to find the actual bearing of the airplane. So remember, we'll find that little angle inside the triangle once we have found x, the resultant speed. And then we can write it in the actual bearing format, or we could go from 0 degrees north and find that direction. It's up to you guys, whichever you're most comfortable with. It doesn't matter, as long as you say, okay, if I'm at the radio control tower at the airport trying to find the actual location of this airplane, what angle would I have to look for?